Okay, so here we have the 10.2 video notes for Algebra 1. Now, these notes are actually going to be probably very short. I mean, this is going to be a pretty short video because this section is honestly very straightforward when it comes to this stuff right here. So, all we're doing for 10.2 is you're just adding and subtracting radicals, okay? Now, the thing with adding and subtracting radicals is the concept of it is almost the same as what we've done before, okay? You can only add and subtract terms with the same radicals, just like terms. So literally, just as you were adding 2x plus 9x plus 2x equals 11x, you have 9 times the square root of 5 plus 2 square root of 5. All you're doing when you're adding is you add the numbers in front. The radical inside does not change. Remember, you have to have the exact same thing in the radical in order to add the numbers out front or subtract, because adding and subtracting is the same thing. So let's go with this one. 3 minus square root of 2. If there's just as if I was doing 3x minus x, I have the number 1 out in front of there. So all I'm doing is 3 minus 1, which gets me 2. With that square root of 2. All right, again, the square root of 2 does not change at all, okay? Those roots do not change. And let me just take a look here. Okay, so, and you know what? Let me do one more just kind of quick example. So let's say like negative 5 square root of 3 plus, 8 square root of 3. So I have the same thing in my radicals here, same thing in my radicals. I'm just going to add the negative 5 and the positive 8. If I add those together, that gets me 3. Square root of 3 will stay the same. And that's it right there. Okay, so let's say if, for instance, I didn't have same radicals. So like for this one right here, I got 2, 5, and square root of 2, all right? Well, I have a common one with these 2's here, but I don't have with the 5. So I can only add these ones here, all right? So what I'm going to do is I'm going to do negative 2 plus 2. Which, if you know, that's going to be 0 square root of 2. And what's 0 times square root of 2? 0. So they'll just cancel out. And there's nothing I can do with that 2 square root of 5. Nothing really to do with that. And I can't break down the 2 square root of 5, so that's it. That's all I can do with that. Okay? Let's go here. 4 square root of 10 plus 10 plus square root of 13 minus 9 square root of 10. All right? I can't do any, so I look for the ones that are common. I got the square root of 10 and the square root of 10 right here. So I can add these together. So I'm going to do 4 square root of 10 minus 9 square root of 10. And again, all you're doing is adding the numbers out front. 4 minus 9, that gets you negative 5 square root of 10. The plus 13, that'll stay down here. You kind of add that on. I can't really add these together. So really, all I can do now is just say that's it. That's the answer I got, all right? You'll only add the ones that have the same exact thing in the square roots. You cannot add the square root of 13 to this at all, okay? Okay, so, okay, just make sure I got a couple there. So I got 5 square root of 3 times the square root of 48. Now, I have 2 here, only 2, and automatically they are not the same. So if they're now not the same, what I can do is I'm gonna simplify the square root down, just like I did above. All right, just like I did like in a 6.1 or no 10.1, excuse me. So I'm gonna list out all my perfect squares, stopping there. Don't care about 1. I want a perfect square the largest perfect square that divides 48. And if you do a little bit of digging, you're gonna see that that number is gonna be 16 because 48 divided by 16 equals 3. So what you can do is you're going to break apart 48 as 16 times the square root of 3. Square root of 14 is going to be 4 times square root of 3. You just add the 3 on there. And then you're going to bring the plus sign down, bring the 5 square root of 3 down. Now they have the same radicals. Radical 3, radical 3. Now they have the same thing. So now what I'm going to do is I'm going to do 5 plus 4 out front. That gets me 9 times the square root of 3, and the square root of 3, well, that just stays the same, okay? Just stays the same there. Do one more down here. 2 times the square root of 7 plus 3 times the square root of 63, okay? I have, so square root of 7, square root of 63. They're not the same. Let's see which ones I can break down. 7, I can't really do anything to break that one down, but 63, let's see what I can do with that. List out my perfect squares here. 16, 25, 36, 49. Stop there. Don't care about 1. These are the numbers I can work with. Let's see here. And if I look, the largest number that divides all of these is going to be 9. All right, none of these top ones work here. So if I do 63 divided by 9, I'll get 7. So now I'm left with 2 square root of 7 plus, break the square. Actually, I'm going to do this over here. 3 square root of 63, break down the 63. I'm left with square root of 9 times the square root of 7. The square root of 9 will become 3. Square root of 7 will just stay square root of 7. But this 3 right here, I'm going to bring this 3 down here. Since we have these numbers out front here now, I'm just going to multiply those, and I'm going to get 9. So I'll get 9 square root of 7. All right, because again, this is just the same. Oops, sorry. This is just the same as 3 times the square root of 63. So you get 9 square root of 7. So that's going to become 9 square root of 7. Now I have the same square roots, same radicals. I can add the numbers out front. 2 plus 9 gives me 11. Square root of 7 stays the same. And that's it right there. That is it right there. All right. Here we go. So here is kind of just a last example here. I just wanted to get another kind of more complex example out there for you guys with adding and subtracting radicals. So this isn't in your notes, but I definitely recommend writing it down somewhere, just kind of as an example. So as you see, you got square root of 12, square root of 27, square root of 48. None of these are the same, radicals, so I can't add them right now. But just as I did over here and I just did above, I'm going to see if I can simplify this. So I'm going to bring this down here. Square root of 12 can be broken up as the square root of 4 times the square root of 3. Square root of 4 is 2 times 3. And I still have that 4 out front there, so what I'm going to do is I'm going to multiply those to get myself 8 square root of 3. All right. The 27, bring that one down. Largest square root to divide 27 is 9. If I do that, I get myself 3. So the square root of 27 is the same as 9 times the square root of 3. Square root of 9 gets me 3. Square root of 3 just kind of comes down right there. And then this 3 also comes down right there. And again, just like I did here, I'm going to multiply these numbers out front here. 3 times 3, that's going to get me 9 times the square root of 3. Bring that plus sign down as well. So do this one here, 48. And as I did literally with this one up here, I can break it apart as the square root of 16 times the square root of 3. All right. Square root of 16 is going to give me 4. Square root of 3, well, let's just stay in as the square root of 3. We're going to bring this 2 down. Bring the negative down first. Bring the minus down. Bring the 2 down. Multiply it. 2 times 4 gets me 8 times the square root of 3. So now I have gotten all of these radicals are the same things. Now I can go ahead and add them together. If I go 8, I'm just going to add these numbers. 8 plus 9 gets me 17 minus 8. Well, that just gets me back down to 9. So it's going to be 9. So if I add all these together, I get 9 with the square root of 3 attached to it. Okay? All right, so those are the 10.2 notes. Thank you guys for listening or watching, and be on the lookout for some new videos.